Alright, in this video we're going to be doing some polar graphing. We're going to work through AP Pre-Cal Homework 10-2. So the first few, we're just going to sketch some graphs. So r equals theta, and we're thinking r is the distance away from the origin, and we're thinking about theta increasing as if we are moving around the unit circle, right? Just thinking about that circle kind of with that orientation, and thinking about distances. So we'll start with when theta equals 0, that will mean r is equal to 0, and there's only one place where r equals 0. When theta equals pi over 2, yeah, I guess I'll just numerically approximate. Pi over 2, it's about 1.5. Pi is a little bit bigger than 3. Okay, when theta equals pi, I'm going over towards the left side of the xy plane, and I'm going 3.14 units to the left. And then 1.5 pi, that would be like 4.5 or a little bit bigger, and then 6.28 would be theta, or when theta equals 2 pi. So, I might have a point like out here or somewhere, but that's going to be off the grid, so I'm not going to draw it. Okay, and so I'm starting off at theta equals 0, like going in that direction, right? But I didn't go anywhere. So I'll go out kind of like that because I need to hit all of the angles between theta equals 0 and theta equals pi over 2. And we graphed this one in class also. I don't think, maybe that's all right. Well, I guess that was probably a mistake because we think it's going to go off the screen, so it should probably be about like that, right? And we can draw that, and there we go. R equals theta divided by pi. Now, this is not one that we did in class, but I feel like maybe we should have. Now, theta in this case, it's not going to be able to run 0 to 2 pi. Because when theta equals 0, r is going to be undefined. I think what I want to do is start with theta equals 2 pi, actually. Yeah, that's what I'm going to do. I'm going to use some color. Be like, okay, when theta equals 2 pi, r equals pi over 2 pi is 1/2. And then maybe I will think about what happens, when theta equals pi. Okay, r would equal 1. Okay, so I'm going to put that one right here. And let's see. I guess when theta equals pi over 2, I guess I'm just making a table. I have to think about this. Pi over 2, yeah, that's going to give me r equals 2. And so it'll be up here. And yeah, so pretty much what's happening is I'm going to go, the closer you get to theta equals 0, the bigger r gets, because you're dividing by a smaller and smaller number. So I think what it's going to look like is kind of like a reverse spiral, where as I am going towards, I don't know, maybe something about like that. That's a little weird. I don't know about the curvature of this graph. I haven't really thought about it that closely. But really, to determine the curvature of the graph, you would need calculus, and that's not what we do here. Oh, wait, I am realizing I forgot a point on the unit circle, and I definitely graphed it wrong as a result. So I'm going to go in and make some changes. I'm going to get rid of that. When theta equals 3 pi over 2, we should probably be checking that also. That would give me pi over 3 pi over 2. That would give me r equals 2/3. Oh, maybe I did. 2/3, I don't know. Oh, that is probably significantly worse. I can disregard that then. Yeah, okay, something much better. R equals 4 on the interval 0 to 2 pi. That's where the distance is always equal to 4 at all points. That's going to make a circle. Let's see how I do. Okay, that's going to be good enough. Okay, theta equals 4. Okay, I'll remind you that's theta equals 4 radians. And I think we need to think about, okay, well, what's that near on the unit circle? 4 radians is bigger than pi. Pi is 3.14, but that's bigger by almost a radian. whole radian. And so think about, okay, well, pi is pretty close to 3, so pi over 3 is close to 1, so 4 would be like 4 pi over 3. And, I don't know exactly, I don't like how this is a grid, so I don't really know where it's supposed to go, but, something to that effect. Where this is the part of the graph where r is greater than 0, and this would be the part of the graph where r is less than 0. R equals 3. This will plot another circle, but this one will only go on the interval 0 to pi, so it'll just be the upper half of the circle. And so label that circle with radius 3. Okay, that's close. Okay, r equals theta from pi over 3 to 5 pi over 3. Oh, man. I think this one would be... I don't know. I don't know. I guess this wouldn't be great to graph on a grid or on a polar, on the polar grid. Anyway, okay, so maybe I'm just gonna go really approximately, and I'm gonna actually. All right, I've decided that blank space would be better for me to write on to show you what I want to show you. So if we're going to start off at theta equals pi over 3 on r equals theta, then r will also equal pi over 3, and that will be, I'm just going to make it that far. Because when theta equals 5 pi over 3, r is also going to be 5 pi over 3, and that's 5 times as much distance from the origin. So I'm going to look and think about that distance, like how far that is, and try to multiply it by 5, and I think that would be right there. And then we're just going to let the distance from the origin steadily increase as we go around, because it's one of these spirals. Okay, just clearly missed the mark there, and think that's about as good as we've got. All right, r equals 4 pi over 3 minus theta, from pi over 3 to 4 pi over 3. So I think this is another one I'm going to want to just sketch on blanks. No, maybe not. I'll just, no, let's do this. All right, so pi over 3, I don't know, but I think it's about there. It's going to be my guess. And then 4 pi over 3, well, that's completely in the opposite direction, so I should just be able to extend that line and be good to go. All right, so 4 pi over 3 minus 1 pi over 3 would be pi. And that's the issue. When I'm starting off here at the beginning of my interval, r is going to equal pi. I'm going to go pi units away from the origin, but I really don't know. I mean, think maybe about here. I don't know. That's my best guess at what the distance of pi would be, but I'll actually label that. And then when theta equals 4 pi over 3, r is going to equal 0. So we're going to end up back here, but we have to hit all of the angles between pi and 4 pi over 3. So I'm going to be, I think we're just doing one of these inward spirals. Maybe I should also do when theta equals pi over, or just regular pi. Yeah, that'll be good. That'll give us another point to aim at. And maybe pi over 2. No, we don't want to do that. When theta equals pi, r is going to be 4 pi over 3 minus pi is going to be 1 pi over 3. So this needs to be a third as far, or about 1 unit away from the origin when I'm at theta equals pi. Oh, okay, yeah, so it's going to be about there. Just a little bit bigger than, or more negative than -1. But I'm going to go over here, and I'm just going to aim for that point, and then I'm going to approach that point from below to make sure I hit all of those angles, and then that's going to be my graph. Yeah, I don't even know how to label that distance there as pi over 3. Okay, that didn't look great, but that's what I've got. Okay, r equals 5, that's a circle with radius pi from 3 pi over 4 to 3 pi over 2. Alright, so those are kind of going to be the bounds of my graph. And I'm going to say, all right, well, r equals 5 the whole time. So it'll be 5 over here, 5 over here. Maybe I can draw a quarter circle that it'll snap to and be real nice. That looks pretty good to me. And then, I'm not exactly that blue line isn't perfect either, but let's see, something would be 5 units away from, it would be 5 divided by square root of 2. But I don't exactly know what that is, so it's going to be, I looked it up, it's like 3.5, so it's probably about right there. And so we'll just draw that as best we can, and that'll be our graph. That actually looks pretty good to me. Okay, r equals 2 on negative pi over 2 to positive pi over 2. Well, negative pi over 2 is down here, and positive pi over 2 is up here. And our graph, 2 units away from the origin at all times, that'll be a circle. It'll map out like this as theta increases from negative pi over 2 to positive pi over 2. I like drawing the circle ones. Okay, now we're going to graph the rectangular form of the equation over the interval 0 to 2 pi, and then also sketch the graph of the polar form of the equation. Yeah, great. I like these problems. So 3 plus 2 cosine x. Just to remind you, remember that 3 on the outside, that's going to give us a midline. 2 is the amplitude. And if it's cosine, that's the one that starts at the top. And at the end of one period is back at the top. Just kind of best we can, estimating halfway. And then the period was 2 pi, and there wasn't any sort of horizontal dilation, no phase shift, so I think that's going to be a good enough sketch for us. When theta equals 0, r equals 5. Okay. When theta equals pi over 2, that would be right here, halfway between 0 and pi, r equals 3. So 1, 2, 3 circles I'm counting out from the origin. When theta equals pi, I am 0 units from the origin, so I'm on the origin. When theta equals 3 pi over 2, r is 3 again. So 1 circle, 2 circles, 3 circles there. And then 2 pi, I'm back to the point I started at originally, which maybe I would emphasize with red. Okay, so going to be better than that. It's coming out, then going back. This is going to make a cardioid. Wait. Oh, goodness. I just thought that was 0 at the bottom. Guess I was looking at the x-coordinate. Okay, when theta equals pi, r is equal to 1, so I'm 1 unit away from the origin. And then it's going to kind of be like a cardioid, but a little flatter on the side. And that's really not a very good graph. And that's kind of my whole point. When I say we really don't need you to produce a whole lot of polar graphs, we need you to look at them and reason with them. And part of building that skill is going to be, graphing a few of them at the beginning, but that's not something you're really going to be asked to do on the assessment. Part B asks, how is the distance between the origin and f of theta and theta changing on the interval pi to 3 pi over 2? It's increasing. Just first of all, look, it's getting farther from the origin as I go that way, pi to 3 pi over 2. But also, pi to 3 pi over 2, r is increasing. This is the graph of r of theta, in a way that we're used to. And since it's going uphill, that means r is increasing, so the distance between the origin and the graph is increasing. We're going to graph the rectangular form of the... Oh, no, so we're going to do a new one. Okay, we're going to do 3 plus 3 sine x, and this one will be more of a cardioid because this one will go down to 0 at the bottom. So 3 in the middle, amplitude of 3, okay, standard 0 to 2 pi period. Okay, pi over 2 and 3 pi over 2 right there. Sine starts in the middle. it goes up. And there we go. There we got it. And then we will start plotting. Okay, I'm kind of using the rectangular graph to think about the polar graph. Theta equals 0, and maybe I should say this is kind of like the theta axis, and this is kind of like the r axis. Where in reality, on the graph on the right, we're kind of still on the xy plane, and r and theta are kind of ideas about distance and rotation. Okay, that's kind of my take on the plane. There's really just one plane. It's the xy plane. We can rename the variables if we want, but like this rotational thing is just a different perspective on the same thing. So when theta equals 0, r equals 3. 1, 2, 3. Then when theta equals pi over 2, r equals 6. Well, I don't have r equals 6 on this graph. That's frustrating. And 3, yeah, I'm just going to make it so that each circle is worth 2. So that would make this 10 and that 10 and this negative 10 and this one also negative 10. Right, so 3 would be 1.5. Wait, no. Theta equals 0. 6 at theta equals pi over 2. Graph that one in blue. 1, 2, 3 circles away. Get back to 3 at theta equals pi. So 1.5 circles. And theta equals 3 pi over 2, r equals 0. And then 2 pi, which is the same as 0. I've got the same radius, so the graph kind of like completes and wraps back on itself, because it's just going to repeat that same graph over and over again. So let's see, I started off here and I went out there, and then I think that's what it's going to look like. It's my best shot at it. Okay, then how is the distance between the origin and f of theta and theta changing on the interval pi to 3 pi over 2? It's decreasing. And the next one's going to be pretty similar. But it's also going to go to 6, so I think I'm going to do the same thing where I'm going to think about this as 10 instead of 5. Okay, but this won't be any different. Midline is 3, amplitude is negative 3, which is really the same as an amplitude of 3, I guess. And we'll just think about that as being negative cosine, which starts at the bottom. No phase shift or horizontal dilation, so I'm going on the usual 0 to 2 pi. Its pi will be halfway in between. That will be where it's at the maximum. It'll be back at the minimum when I get to 2 pi. Okay, I'm going to put these points in there, connect them with a sinusoidal graph that can be better than that. Okay, there we go. And start theta equals 0, r equals 0. That's the origin. Okay. Also known as the pole in polar world. So pi over 2, r equals 3. That's going to be 1.5 circles away. Theta equals pi. That's 6, which is 3 circles away. Theta equals 3 pi over 2, r equals 3, which is 1.5 circles away. And then theta equals 2 pi, and back to where I started at the origin, or at the pole. So I think that might be, I don't know about drawings of these. I think it's actually more like that than I've been drawing it, but that's kind of the thing, is that we know what's going to be on the free response section of the AP Pre-Cal exam, and drawing polar curves is most certainly not one of those things. That is a multiple choice only thing. So that's where we would have to just be like reasoning with a picture of the graph, or a description of the graph, or maybe choosing the right graph from an algebraic equation. Okay, how's the distance between the origin and the graph of the polar curve changing on the interval pi over 2 to pi? Okay, well, we're just going to look on pi over 2 to pi. It's increasing. So I'm going to say, all right, distance r is increasing. Okay, and I do recognize that there is more to it than that, like in the bigger picture, but in this problem set, we are looking at situations where r is only 0 or positive and never negative on these graphs, and so it is actually as simple as looking at the underlying rectangular function and saying, is it increasing or decreasing? Because we are always, we have r always positive or 0 here, never negative. So graph the rectangular form on 0 to pi. Okay, I was going to say, I'm talking about how we're staying positive here, but this will stay positive. So y equals 4 sine x, no vertical shift, so the midline would be 0. Oh no. About right there. And then I'm going to graph it on, since it's 4 sine x, and we're used to graphing this on the one full period, I'm going to do that. I'm just not going to, finish the curve after right there, halfway to 2 pi is pi. And so if I was going to graph it, sine starts in the middle and goes up, and so I'd have a point over here as well, but I'm only going to be graphing that so I don't get tempted to graph too much on the other side. Okay, so when theta equals 0, r equals 0. I'll plot that one in red. That's at the origin. Then when theta equals pi over 2, r is equal to, the amplitude was 4. Let's put that up there. So it would have gone down to -4 had I been interested in that. Okay, theta equals pi over 2, r equals 4, which would be right there. And then when theta equals pi, r equals 0. So I'm back to where I started. So I think to you, the best you know, like it goes off to the side, goes up, and then like you could definitely think it looks like that. I'm just going to tell you that the graph is actually an actual circle. So something a little bit more like that. Okay, now if it asks about on the interval pi over 2 to pi, okay, that would be right here on the graph, on the rectangular graph. Okay, r is decreasing towards 0. Okay, r is getting closer to 0, the curve is moving closer to the origin. Okay, but we're also, I don't know if you can really see it at the beginning, but really as you keep going on that part of the curve in the polar world, you could definitely see you're going towards the origin. I think it would be believable to think at the very beginning when you're going straight to the left that you'd be going away, but we can see on the rectangular graph that you're actually not. You're going towards the origin on the entire interval pi over 2 to pi. Okay, so distance is decreasing. Right. And now we've got just another one for cosine x on negative pi over 2 to pi over 2. Okay, now that's interesting. Let me think about that. I think what I'm going to do is I'm just going to graph it in a way that I don't usually, and graph it from negative pi to pi. Okay, negative pi to pi will still give you, it's 2 pi's worth of graph. And I'm just going to think about cosine of negative pi, cosine of 0, and cosine of positive pi. Yeah, so I've got no shift in the midline. I'm going to go up by 4 and down by 4. And I'll really only need kind of the middle part of the graph, but there we go. Oh, but we'll get there. Okay, when x equals negative pi, cosine of x equals -1. So that would be 4 times -1 is -4. Okay, so this one's going to start at the bottom. It's going to end at the bottom. And otherwise, it's just going to be a regular cosine. It was just kind of a question of where does it start. Now we could check this other point here. Cosine of 0 is 1. 4 times 1 is 4. Okay, that feels good. Cosine of pi, also -1. Okay, yeah, I've got it right. Okay, so I'm going to put these points in graph. But wait a second, don't care about that interval. And then I've got it going up and going down, and there we go. Okay. And then I'm going to plot these points. Okay, r equals 0 at both of these places. Okay, that's That's r equaling 0, but that corresponds to negative pi over 2 and positive pi over 2. So my graph, provided that r of theta is actually positive, should be to the right of this. Like it'll be, over here somewhere. I don't know, doing something weird, but definitely to the right if r is positive. And, or, I guess really like it could be, looking at something like that. But it should be probably more regular. When theta equals 0, r equals 4. So 1, 2, 3, 4 right there. And negative pi over 2 to pi over 2. Yeah, so, and I think this one, maybe I would talk about, oh yeah, when theta equals negative pi over 4 and positive pi over 4, you'd have these places, and I don't really want to get into their actual value, because it's got a square root of 2 in it, and that just, I think, doesn't really help. But r is positive over there. So when theta equals negative pi over 4 down here, r is going to be positive, and I think it's going to be, say around here. And then when theta equals positive pi over 4, r would be having about the same thing happening there. And that's where I'm saying it's going to be another circle. The graph of, I think, some number of sine x's was the last one, and this graph of some number of cosine x's, that will trace out a circle. And with any luck, yeah, it looks pretty good. And if we're thinking about how the distance from between the origin to the graph of the polar curve is changing on the interval 0 to pi over 2, it is decreasing. Okay. Now, 4 cosine of 2x on the interval 0 to pi over 4. This should be a little more interesting. Okay, so much like the other one, midline 0, amplitude 4, but this 2x, this is going to be a horizontal dilation by a factor of half. Okay, so that means that instead of going from 0 to 2 pi, I'm going to be going from 0 to 1 pi, making this pi over 2 and this pi over 4. Okay, and so I need to... Yeah, okay, that's fine. I think I see what we're getting at here. We're doing a small portion of the curve, and we're going to do the rest of it, at a later time, probably next time. Okay, and cosine is the one that starts at the top. So it would look like this if we were going to graph the whole thing, but we're not. We're only graphing that portion. And on the interval 0 to pi over 4, I might start with this question. The distance is decreasing. At the beginning, at theta equals 0, r equals 4. And at the end, when theta equals pi over 4, r is going to equal 0. And it's going to be decreasing the whole time. And the other thing is, and I'm going to get like a gray pen, because this is kind of an important idea. Okay, right there, where theta equals pi over 4. I can't go beyond that, right? Because that's the maximum angle input. So just as I'm letting theta increase and r decrease, I need to stay under that line, but kind of approaching that line as I go towards the origin. And that's kind of the finer details of polar graphing, which I'm not sure you need to totally master. I think you need to be looking at the main points, which is why I've been labeling them in like red and blue, with the big stops on a given graph. That's what we need to be looking at to determine which is the right graph or which is the right equation for a given graph. Okay, and I think that's all we need to do with that one. That was just a portion of what would be a rose curve if we graphed out the whole thing. Okay. 5 sine of 3 theta. Yeah, it doesn't matter if it's the input variable is theta or x or whatever. We're graphing on the box the way we used to, and then we're going to graph it in a polar world. So y equals 5 sine of 3 theta. So it's going to start at 0 and have an amplitude of 5. And okay, 3 theta means that it's been horizontally dilated by a factor of 1/3. So this would be 2 pi divided by 3. Halfway would be 1 pi divided by 3, and that's what we're looking at. And halfway there would be pi over 6. Okay, and let's see, it's sine, so it's going to be starting in the middle, coming back to the middle, and ending in the middle. Starting in the middle, going up, then going down, then coming back. Okay, and then, okay, but wait, we were only graphing on 0 to pi over 3, so let's get rid of that. That's not really what we're interested in. Okay, when theta equals 0, r equals 0. When theta equals pi over 6, r equals 5. So I'm going to go to pi over 6, which is right there. Go out 5 circles. 1, 2, 3, 4, 5. And there I'll have some graph. And then I'm coming back to theta equals pi over 3, r equals 0. Okay, so I'm back to that red point. Okay. But because the limits of the graph need to be 0 to pi over 3, I'm going to draw that in on the graph. And now I know my graph needs to stay inside those, two gray lines. And so I'm going to r is going to increase as theta goes from 0 to pi over 6. So I'll go like that. And then r will decrease as theta increases from pi over 6 to pi over 3. And there I get a loop. And that'll be, again, kind of similar to what we were looking at before, part of a rose curve. And then, oh, I forgot, it's going to ask me how is the distance between the origin and the graph of the function in the polar world changing on pi over 6 to pi over 3. Decreasing. Right, and then is this, yeah, I think this is the last one. So graph the rectangular form of the equation 5 cosine of x divided by 2. So this one's getting horizontally dilated by a factor of positive 2, meaning I've got, okay, but we're only going 0 to pi. So if it got horizontally dilated by a factor of 2, instead of going from 0 to 2 pi, I'd be going 0 to 4 pi. And so that would make halfway be 2 pi, and then half of that be 1 pi. And then, all right, cosine is the one that starts at the top and ends up back at the top, and give it a little bit of that, but we're only interested in the interval 0 to pi, so I'm going to stop graphing right there. Okay, there would be another point there, but that's not what I'm interested in. A midline 0, amplitude 5, and here I've got r is decreasing. Once again, it seems like it's been decreasing a lot. And, whoops. Okay, when I go to plot this on the polar axes, I've got theta equals 0, r equals 5. Okay, then theta equals pi, r equals 0. Okay, now this is interesting. Okay, so notice that r is going to need to be positive the entire time from 0 to pi. So I'm going to need to have some graph, like in that area where theta is between pi over 2 and pi, and r is still positive. Okay, so it's not going to be that. That would be wrong for sure. Okay, that would be basically saying that r had arrived at 0 before or at theta equals pi over 2. So 5 cosine of x divided by 2. I think I want to think about theta equals 2 pi over 3. When theta equals 2 pi over 3, r is going to equal 5 times the cosine of not 2 pi over 3, but 1 pi over 3. Okay, so remember, cosine of pi over 3, it's going to be the short leg, that's a half. Okay, so r is 5 divided by 2 is 2 and a half. Okay, so when theta equals 2 pi over 3, I'm going out 2.5 circles. And I think that'll help as I go to kind of sketch the graph here. So it's going to be, I think, looking... And what happens when theta is pi over 2? 5 times root 2 over 2. So it's like... That's my best shot at it. I'm not really sure. If you want a good graph of this, use technology. Go to Desmos.com, pull out a handheld graphing calculator, do whatever you're going to do. But that's the last example for this homework set, so that's going to be all for the video. Thanks for watching.